Okay, today we are going to go back to 18b a little bit, the derivative, right? So 18b, the derivative. Charlie, what is the, can you give me a definition of the derivative? What does that even mean?
Isn't it like the gradient of a line?
Yes, you're close. It gives you the gradient function. Okay, the derivative gives you the gradient function. And what does the gradient function do? Sarah, can you give me a verbal explanation of what the gradient function is used for? What do you use it for?
Use it to find
Yeah. I something instantaneous.
instantaneous rate of change.
Yes, IROC. Yep. Which is also the
Tangent.
not exactly the tangent. It's something about the tangent. The gradient of the tangent. Yeah. So the gradient function is, it's called the gradient function for a reason, right? It's used to find the gradient. Okay. Used to find the gradient. And this one has many names, so it's either the gradient, the instantaneous rate of change, right? So just to find the gradient at any point on the function, curve, say on the curve. Okay, all right. So a quick recap. For example, if we have a function that looks like this, what's the graph of this? What do you guys think the graph of this is? Y equals to?
X squared?
Yes, y equals to x squared. Very good. And let's just say the gradient function, I told you guys the notation, right? So let's say this is fx equals to x squared, then the gradient function is, or the derivative is f dash of x. Okay, the dash is very important. Okay, it's f dash of x, and what was it? I think we calculated last time, it was 2 times x. Okay, what that means is, let's just say at x equals to 1. So let's say the point is 1, 1, right? At x equals to 1, f dash of 1, so when you substitute 1 into the gradient function, you get 2 times 1, which is 2. This means that the gradient of the tangent, or the instantaneous rate of change, is equals to 2. So this one would be y equals to, so this one, the gradient would be equals to 2. Alright, so the gradient is equals to of that line. Does it make sense? Mm-hmm. Yeah, so positive gradients will slant to the right. So how about at, let's say, at x equals negative 1. Right? At x equals to negative 1, then f dash of negative 1 would be 2 times, put the value in, negative 1 is negative 2. Does that number make sense?
Yeah, because the line's like going down.
Yes, correct, because the line is going down. Very good. So this is the point, x is negative 1 and y is still 1, right? Because when you substitute negative 1 in here, you get, so f of negative 1 is negative 1 everything squared, which is positive 1. That's the y coordinate. Okay, and now if we draw the tangent line at that point, so this one has the gradient of negative 2, right? It's a negative gradient because it's going down, right? Negative gradient just means like at that point the graph is going down. When you go from left to right, it's going down. Okay, make sense? Yeah. Now, so that's the recap on the meaning of the gradient function, the derivative. Now we'll look into how to find the derivative. Okay, and I'll use one of these examples again. So have a look at question 2a. Okay, so I'll rewrite it. So the derivative of y equals to x squared plus 1. So what is the formula for the derivative? Like the original way to find the derivative is actually equals to limit of h to 0. So h is the distance between the 2 points. Remember, we're calculating the average rate of change between 2 points. Yeah, remember this one there, the one where you do 2 points, right? And then we're trying to find 1 point. What happens when 1 point gets closer and closer to the other point? And what does the gradient of that line becomes? So that would be, this is essentially the idea of rise over run. The top is the rise, which is, so the rise which is f of x plus h minus fx. Okay, so this is essentially the y of the second point. y of the q point, and then this is y of the p point. Right, and then everything is over the x of the q point minus x of the p point, right? And that would be over just h. Right, so this formula is something that you guys will need to basically remember for unit 2. All right, just need to memorize this. So now, what is fx? So given this equation here, right? Sarah, what is fx?
X squared plus 1.
Very good, x squared plus 1. Charlie, what is f of x plus h? If fx is this, then what is fx plus h?
What's this?
So we are finding the rise over run, right? And then remember there are 2 points. The first point is where the x value is. Oh, whoops. The first point is, so at the point P, it's just x, right? And then at the point Q, it's x plus h. Yeah, that's why we're finding the y coordinate at point Q, which is f of x plus h. And then the coordinate at point, the y coordinate at point P is f of x. Yeah, so what's fx plus h then? Remember, the main idea is it just means that you put x plus h in any x that you see from the fx equation.
What do you mean? Just from the original, just
Yeah.
x plus h squared plus 1.
Yes, it's x plus h, everything squared plus 1. That's it. Okay, so then if you substitute this into the formula, that would be lim of h to 0 of fx plus h is your x plus h, everything squared plus 1, and then minus fx. Now, fx has 2 terms in it. It has x squared and it has 1. When fx has more than 1 term, you should put the both of them in the brackets because you're minusing the whole of fx. Okay, so that's minus of x squared plus 1 over h. Okay, any question there?
No.
No? And next is we're just expanding, and so at this point here, what's the step that we're thinking of? What do we need to do at this step here? The goal. What's the main goal? Sarah, what's the main goal at this step here?
To cancel h.
Yes, perfect. Goal is to cancel the h in the denominator. Very good. So to cancel that, we'll need to expand the top, right? So lim h to 0 and then expand the top. What's x plus h everything squared expanded, Sarah? Expand this term here.
X squared plus 2xh plus h squared.
Yes, perfect. And then plus 1 and then minus x squared minus 1. Yeah, because remember when you open the brackets, then the negative will distribute into each of the terms, and then everything is over h. So looking at this one, you see the x squared cancel each other out, and then the 1 cancels each other out, which means it's just lim of h to 0 of 2xh plus h squared over h. Right, and that would be lim of h to 0 of 2x plus h. And this is essentially thinking of when h goes to 0, this one also goes to 0. So the answer is 2x. Okay, so then the derivative of the equation of f dash of x is equals to 2x. Now you guys today will learn another notation, which is another way of writing this is when you derive y with respect to x, this will be equals to 2x. So dy over dx or d over dx is another way of writing the derivative is equals to. So the derivative has many forms. One would be the f dash of x, and then the other one would be dy over dx or d over dx. Okay, so I'll write a quick note here, derivative. So this is the gradient function, right? It gives you the gradient function. And there are many names to it. You can they will either write it as f dash of x or d over dx or dy over dx. Okay, so over time you guys will learn which format is used where. Okay, any question? No? All right. Let's start question 2b. Now let's try question 2b on paper. Blake, if you're listening to this recording, you should try out this question 2b by yourself as well, and pause the recording if you need more time before looking at my solution later. Are you finished with that one, Charlie?
Yeah.
Any issue?
What set of the answers?
2x plus 2, right?
Yeah.
Yeah, let's see. So when you cancel the h out, there's still a... Right, so when you cancel the h, right, this one is plus 1h, and there's only plus 2. Because this is h times h, right?
Oh, okay, yeah.
Yeah, and then the other one is 2 times h. So when you cancel out the h, there's still a constant 2 left. Okay, Sarah, any question? It's best to rewrite all the terms first before you cancel it. So we 2xh, see that third line from bottom there? This one would be 2xh plus h squared plus 2h. Right? So don't do the cancellation of the h first. Right? So the next step should just cancel out all the other ones and subtract each other out, and then do the h cancellation on step after. Okay. If you fix that up, yep, move on to C. Okay, did you got 13?
Pardon?
Did you get 13?
Yeah.
Okay. Okay, good. Alright, very good, very good. Okay, if you're done with that, have a look at example 5 and then see if you can start on question 3a, because I'll start on that one next. 3a. Okay, get 13?
Maybe like after you substitute 0.
Yes, that's right. And look, this is 3h, right? When you divide by h, it's 3. Yeah, you're not subtracting h, you're dividing by h. So it should be plus 3, yeah. And yes, you do substitute h equals to 0. And that should give you 13. Okay, alright. Everyone have a look on the screen there. I'll walk you guys through example 5. Okay, so the textbook version of it is quite, I would say it's sometimes it's a bit hard to understand, so I'll use a more detailed explanation for this example. Okay, so remember what's the formula? Okay, Charlie, what is the formula for finding f dash x?
F of x plus h minus.
Wait, it starts with lim.
Oh, sorry, yeah.
Mm-hmm.
F of x plus h minus f of x over h.
Yep, f of x over h minus f of x over h. So if we know that this is formula, right, then the hardest thing, I'll tell you guys, the hardest thing to find out is the f of x plus h. Okay, that's actually the hardest thing. If you get that one wrong, it's very hard for you to get the whole thing right. So you would find fx plus h first. Okay, so for this question, I know fx is this, which means I'm just going to calculate f of x plus h, right? And then I can even expand that straight away. So remember, fx plus h just means whenever you see x, you put x plus h. Okay, so put the brackets around it and put x plus h. So in this case, instead of x squared and then plus 2x, right? When I see x, I put a brackets, turn that into x plus h. When I see x, I put brackets, turn that into x plus h. Okay, that's essentially the procedure to find fx plus h. And then you can even expand that. You should expand that and work it out fully first because you don't want to expand it in the formula. So then expand that one plus 2xh plus h squared plus 2x plus 2h. Okay, and see if you can simplify anything. Well, we can't really simplify anything, so we'll leave it as it is. This is your fx plus h. So now then we can write f dash x, or the derivative, is equals to lim h to 0. Remember, we're always finding lim h to 0, yeah? Finding what happens when the distance get closer to 0. And fx plus h, which is, you can go straight to the answer here. So actually, just write the formula. Fx plus h minus fx over h. So always write the formula, because trust me, in the exam, if you get everything else wrong and you write the formula, I'm pretty sure you get 1 mark. If you get the formula right. Okay? So always write the formula. So then that would be equals to lim of h to 0, and now just put the values in. Okay, so it's going to be x squared plus 2xh, I'm just reading that line there, plus h squared plus 2x plus 2h. Now subtract, remember when we have two terms, right, so x squared and 2x, when we have two terms of fx, what do we have to do here, Sarah? When we do the subtraction, it will be subtract. Because we're subtracting fx, right? So we need to put the value of fx in here, but fx has two terms. So to do the subtraction, you need to put them in. Because if you don't do anything, right? If you write it this way, this is wrong. Why? Why is it wrong? If you just put it in like this. Charlie, why is this one wrong?
Because when it's in brackets, so then you're subtracting 2x as well as...
Yes, very good. So technically, this one should be in brackets. And when you expand the brackets, it will be subtract x squared, subtract 2x. Yeah, because the negative will distribute into each of the terms in here. So when you have two terms, you need to make sure you put that in brackets. Okay, and then everything is over h. Okay, this is a very long question, right? Quite a long question, but just bear with me, work through that. So well, if you can, so Sarah, if you can, if you don't want to put the brackets there, you need to make sure you turn this into a negative straight off. Okay, if you can. Right, but otherwise I still recommend to put the brackets first until you're used to it. But yeah, after that it's just cancelling out any terms. So anything that doesn't have h normally will just get cancelled out. Okay, so that would be 2xh plus h squared plus 2h, everything over h. Now cancel each of the h out. So 2x becomes 2xh becomes 2x, h squared becomes h, and 2h becomes 2. Okay, so that is lim of h to 0 of that, which is 2x plus 2 is the final answer. Okay, any question? No? Alright, try question 3a. So remember, find fx plus h first and then just apply the formula. Make sure you write the formula before you substitute the values in. Okay, and start on 3a.
Would it be 3x plus h squared or 3x squared plus h?
3 and then brackets x plus h squared, close bracket squared. So for question A, be very careful because there's a 3 in front of x squared. Make sure you keep that outside of the brackets and then times it into each of the terms after. So I've done f of x plus h there. If you want to double check that first. Make sure you get your fx plus h right. And then the rest is just a formula. So yeah, Charlie, your fx plus h, right? I would expand that first before putting it into the formula. Yeah,
put it in expanded?
Yeah, put the expanded version into the formula straight away. Because otherwise you have to write like 2 more lines to expand that.
When you're writing it out, is it just like minus x?
Minus or 3x squared?
Is that it? Like because in all the other ones there's like...
Has 2 terms.
3 like x plus h. You know what I mean? Like this one has like x plus h squared plus 2x.
Oh yes, yeah.
So do I do that for this one as well or not? Because this one has like plus 2x here.
Yeah, so this is the fx term, right? And that's why when you do fx plus h, it has 2 terms. Yeah, but it's just essentially fx plus h. No. So once you expand it, this thing will go into where that thing is, right? This whole thing goes there, and after that, just minus fx, which is minus 3x squared. That's it. Okay. Sarah, any question? Let's see. So, okay, so the first expansion is of the square, right? Just expand the square first, ignore the 3, expand the square, but the 3 is still outside, multiply into the brackets. So that's why it's a 3 and then that'll be x squared plus 2xh plus h squared. Right? Because that's just the binomial, that's just a perfect square expansion. Right? So do the expansion first, but keep the 3 outside of it, and then you times the 3 back in after. That's the tricky part about question 3. Yeah, we're going to do as many of question 3 as possible.
What do you do for question C for 3?
Give it a try, okay? I want you to try that first, and then I'll go through the answer with you. I want to see what sort of creativity you have, or if you actually get the idea first. Just follow the rule. When you see x, you sub in x plus h. Otherwise, you don't sub in x plus h, and then you just keep going.
But isn't
That's
this
it.
just a straight vertical line?
Yes, you're correct. Well, it's a straight horizontal line because y equals to a value, so that's a horizontal line.
Oh, sorry. So it doesn't have a gradient, then, right?
It has a gradient of a special value. Try it, work it out. You know, the worst thing you can do is get it wrong, right? But that's fine.
I think I did it wrong, Corey.
Let's see.
No, don't look.
Okay. See if you can fix it first. Feel free to check through check the answer and see what the answer is supposed to look like, and then see if you can
So
fix
it's
it.
0, which I thought it would be 0, but
If you thought it would be 0, then you'll be correct. But the working out will also get you to be equal to 0 as well. If you
because you do 3 plus, or you do x plus h squared, right?
no, there's no x in there. What are you talking about? Is fx equals just 3?
Yeah.
Yeah.
But then don't you do f of x plus h as well, or not?
Yes, you do have to find fx plus h, and what is that equal to?
3 as well. But do
Yeah.
you square it again?
No.
Or not? Do you just leave it
It's
as
just-
x plus h?
It's just 3. There's no x, so it's just the same thing.
Then how can we square it for all the other ones? You do x plus h squared.
Because the other one has x in it. And so when you put x plus h into the x, it turns into something else different.
Okay.
Right? But for question C, there's no x in it. So it just stays exactly the same. Okay, Sarah, any question for me? Let's see. Yeah, okay, yeah. Yes. Wait, 6? Oh, yeah, 6, yeah. That's right, yeah, 6x plus 3h, yeah, which is 6x. Yeah, correct. Okay, yeah, keep going. Now we'll do as many of question 3 as possible, including B and C. So note that B and C are not hard, but they just feel a little bit different. Or C feels a little bit different. But the rest of the questions not that different. This is called finding the derivative from first principles. If you guys can do this comfortably, well, when the exam comes, you will get this question. This question will almost always come out for Unit 2 exam. Right? One of these ones will almost always come out because this is the only time that actually comes out in the whole of math methods. In Unit 3 and 4, you don't have to do this anymore. And the reason for that, you will know in the next chapter. Right, answer for B is up. Are you good with that, Sarah? Did you get 4? Yep, okay, alright. Now, Charlie, please continue with the other questions. So, Blake, I will pause the recording here. The second half will be on chapter 18C.